The next observation was effect of potential on photocurrent. See, when we talk about effect of potential, remember during the experimental setup, I mentioned that the collector could be negative or positive with respect to the emitter, correct? So, usual experimental setup was collector will be positive, emitter will be negative, so that all the electrons are being collected, right? Now, there was one example which I gave where the collector was kept at negative and emitter was kept at positive potential, so that it will repel the electron, right? So, we will see what is going to be the effect of this potential on the photocurrent. Okay. Now, what we'll do is, see, first we'll keep the collector potential and emitter potential. Okay. So, let's say collector potential was at 2 volts and then photoelectric effect happens. So, some of the electrons are being repelled because it's at negative potential, right? So, the collector is at minus 2 volts and the emitter is at plus 2 volts. Okay. Now, some of the electrons will be repelled because of the negative potential of the collector, right? But then, even then, some of the electrons will come and reach the collector because of the energy what they gain from the radiation. Now, let's say collector potential got increased to minus 5 volts. See, now what happens? More number of electrons are being repelled, but still some of them will come and reach. Let's say I'll increase this to minus 8 volts. Very small, maybe like 1 or 2 electrons will come and hit it. Let's say I increase this to minus 10 volts. Now no electrons will reach. Meaning, see, how was the frequency and kinetic energy related? They were directly proportional, correct? So here what we have is the maximum potential what can be given to the collector so that no electron will come and reach the collector. So this is the maximum potential, correct? And don't you think this will be the maximum kinetic energy of the electron? Because no matter how fast the electron moves, that is being repelled, correct? That is being repelled. So in this case, what we have is the maximum kinetic energy. So K max is equal to EV naught, where V naught is called as stopping potential. Okay, see, if you look at the graph, this is how the graph goes. See, all of them will come at, they'll stop at V naught, correct? So, go ahead, you can pause and look at the video for a while. Look at the graph for a while. See how the graph goes. Look at the x-axis, look at the y-axis, look at the intensity of current, and then why all of them are reaching at V naught and stopping. So, go ahead, pause for a few seconds. So, as you can see, all of them will stop at one point, correct? Now, here one very important point is the kinetic energy or the velocity of the electrons are independent of intensity of light, because intensity gives more number of photoelectrons. It will not increase the speed. To increase the speed or velocity of the electrons, only frequency has to be increased. So, keep this in mind. The velocity is dependent on frequency, or you can say kinetic energy is dependent on frequency, whereas kinetic energy is independent of intensity. Okay, so this was again one of the most important experimental observations of photoelectric effect.